Now I've got a really terrific diagram over here. I've got a picture here of this guy is the volts, so he's providing the push, he's providing the electrical potential energy, so he's giving the current the energy to do work. This is the actual current. So this is the guy. He's sweating it out a bit here. This guy's the actual current. So he's the charged particles, I suppose, but he's a measure of how many charged particles are flowing. And you can see that if the voltage, if I'm pushing lots pushing the current lots, I can push it quite a bit. But my resistance up here, he's stopping the flow of the current. So he's making the current flow less. So the volts is giving the current the energy, but the resistors is saying, well, no, you can only have a certain amount of current flowing through here, and he's making the pipe smaller so that less current can flow through. So that's a bit of a fun diagram to look at, voltage, current, and resistance. But you can see with that diagram that they all do relate to each other. And because they all relate to each other, we can actually calculate things by having a look at if we've got a couple of if we know the voltage and the resistance, we can figure out the current. And we do that using something called Ohm's Law. I've got a diagram here of Ohm's Law, and it's V. I've got in a triangle here, V, I, and R. And what this means is that if we are given, if we want to find out the resistance, then the resistance is equal to voltage divided by current. So resistance is equal to voltage divided by current. If we wanted to figure out the current, then we'd look at the other two, and so the current is equal to voltage divided by resistance. Again, that's over here. Current is voltage divided by resistance. And the last one, if we want to know the voltage of an electric circuit, then it's just current times resistance. So again, voltage equals current times resistance. And you can use Ohm's law to calculate things about electric circuits. So I've got a bit of an example here. So if you had an electric circuit and someone said, well, what is the voltage across a 50 ohm resistor when the electric current flowing through that circuit is measured to be 250 milliamps? Well, you say, okay, well, so what are you asking for here? What is the voltage? So we need to find the voltage. And fortunately, this is Ohm's law. The voltage is equal to current times resistance. Voltage is current times resistance right here. And we know the current, but really importantly here, when you're doing Ohm's law, you have to have the volts in volts. Voltage has to be measured in volts. Current has to be measured in amps, not milliamps or microamps, but amps. And resistance has to be measured in ohms. So again, I'll draw that. So volts is measured in volts, that's quite easy. Amps or current is measured in amps, and resistance is measured in ohms. So you have to make sure you have all of those three standard units correct. So here I've got, what's my voltage? Well, my current is 250 milliamps. Well, that means a milliamp is 1,000th of an amp. So it means I have to move my decimal point 1, 2, 3 times to make it 0.25 amps. So 250 milliamps is 0.25 amps. And we know that the resistor is a 50 ohm resistor. So voltage is equal to 0.25 amps times 50 ohms. And what does that equal? Well, if you use a calculator, the voltage then equals 12.5 volts. So I can use Ohm's law to calculate either the voltage or the current or the resistance in an electric circuit, and scientists use that all the time. So that's all about Ohm's law. It's V equals IR, I equals V divided by R, or R equals V divided by I.